Hello everyone, my name is Basanta Bhatta and I am a graduate student from the Department of Civil, Coastal and Environmental Engineering. Today I am presenting on a topic titled Sea Level Rise and Transportation Infrastructure as part of the coursework requirement for the final project in the subject Introduction to Coastal Engineering. In this presentation, I will be discussing on the following topic. First of all, I will discuss about what sea level and sea level rise is. Then I will present some of the causes of sea level rise and then discuss on the possible effects that could arise related to the transportation infrastructure due to the sea level rise. After that, I will be discussing on possible preventive measures and then end the presentation with conclusion and some references. So before discussing on what sea level rise is, first we have to understand what sea level is. Basically, sea level is the average height of the water on oceans. And when talking about sea level, we usually refer to as the mean sea level. There are two ways in which we can measure the sea level. One is through the use of the water gauges, in which we have to take the reading of individual ocean height at different times and then have to take the average of those readings to get the mean sea level. And the sea level calculated with this type of measurement is known as the local sea level, as seen on the figure 3. Similarly, there is another method in which satellites orbiting around the Earth measure the sea level constantly, and this type of measured sea level is known as the global sea level, which is mostly used. And we also know that the global mean sea level is a type of vertical datum as well. And talking about the sea level rise refers to the average increase in the water level of the Earth ocean. So whenever we see an average increase in water level of ocean, it is referred to as the sea level rise. According to the report published by Intergovernmental Panel on Climate Change, uh, which in short also called as the IPCC, they mentioned that the global sea level rise would occur in a range of 0.45 to 0.82 meter in 21st century. Figure 2 also indicates the similar trend. Here we can see that from the year 2080, the slope of the global sea level rise is stiffer than the previous centuries, from which we can say that sea level will increase in the future. Then why we see the change in sea level? The main cause of sea level rise is due to the human activities that has resulted in a climate change. Apart from that, other basic causes of sea level rise can be considered as number one, thermal expansion of ocean water. Due to the global warming, not only the temperature of land area, but also it has led to increase the ocean water temperature. When this happens, the water expands and volume increases, which leads to periodic rise in sea level. Similarly, another cause can be considered as melting of mountain glacier and ice sheets. Typically, ice formation in mountain like glacier melts during the summer and contributes to the ocean water. Due to global warming, however, summer temperatures are increasing, which is resulting in the large volume of glacier meltdown and greater runoff. As shown in figure 4, your area of the glacier ice between mountain is decreasing. Consequently, in the year of 1960 and 2015, not only the summer temperatures, but nowadays snowfall has also been decreasing due to the late winters and early springs, which in combined with the temperature rising summer temperature has resulted in the sea level rise. And the third cause can be considered as loss of ice sheets in Greenland and Antarctic. Similar to the mountain glacier ice melting, due to the global warming, Greenland and Antarctic ice area is also decreasing every year, which is resulting in increased runoff and ocean water level rise. This is the overall phenomenon that causes the sea level rise. Here we can see ocean thermal expansion, melting of mountain glaciers, melting of polar ice sheets and glaciers, which is related to the Greenland and Antarctic ice as discussed earlier. Similarly, sometimes the geological process of solid earth deformations like uh, land emergence or land subsidence also lead to the sea level rise. The red numbers in percentage here indicates the contribution of each phenomenon on the sea level rise between 1993 and 2018. Here we can see that thermal expansion of water accounted for 42%, melting mountain glacier accounted for 21%, and Greenland accounted for 15, and Antarctica 8%, which in combination contributed like 23% for the global sea level rise. Now, let's discuss on the effect of sea level rise on transportation infrastructure. It can be said that sea level rise affects various aspects of transportation infrastructure, especially in the coastal areas. Initially on the road and bridges, considering that one of the major effects of sea level rise is that it increases the risks of storm surge and flooding, which can cause a road surface to crack or wash away due to the increased water pressure or salt intrusion inside the pavement layers. Similarly, it causes roadways and bridges to be submerged or eroded. As seen in Figure 7, according to the NOAA, it's a storm surge on the Louisiana Highway that shows the effect of rising sea level in the Gulf of Mexico. Consequently, in bridges, it can cause unsetting and displacement of bridge spans. The picture on the right, that is Figure 8, is a picture of Escavia Way Bridge that carries I-10 across the Escavia Way near Florida, Pensacola, Florida. In 2004, it was heavily damaged during the Hurricane Ivan, and according to a research article published by Dr. Wave and co-authors, it was highlighted that 36 years of relative sea level rise resulted in the higher storm surges and larger wave heights, which led to the greater wave-induced loads and eventually resulted in the bridge damage. Therefore, these types of effect in bridges and road causes disturbance in traffic flow and also damages the vehicles and equipments. But the important thing is that these effects reduces the accessibility for users in case of emergency services, since most of the used mode of transportation is kind of a roadway. So railway is also the another mode of transportation which is affected by the sea level rise, generally due to the flooding and sinking of track beds. Due to the compaction of the marshy soils, railways are mostly affected. Apart from that, rising sea level can damage and score the railway infrastructures and provides the structural damage. Uh, Figure 9 on the left bottom is a breach in a seawall in UK. This damage was considered to be caused by the high sea water in which the track was left hanging in mid-air as seen in the picture. Similarly, sea level rise can cause flooding in the low tracks and tunnels as well. Figure 10 on the right is of the Newark subway, which is assumed to be particularly vulnerable to these events, and this was flooded after the superstorm Sandy. Next is in the aviation sector. Uh, since this mode of transportation is miles above the sea level rise is not likely to be a serious problem to this type of transportation. However, coastal cities like Boston, Newark, and Washington have some airports in low areas that makes the runway vulnerable to flooding. According to the data from the Airport Council International, about 25% of the world's 100 busiest airports are less than 10 meters above the sea level. which shows that these airports can be affected anytime by sea level. Similarly, another report published by some researchers mentioned that globally airport disruptions could increase by 17 to 69 times by the end of 2100 AD, and Southeast and East Asia are at the highest risks of that one. Figure 11 on the slide shows the San Francisco International Airport, which was flooded during the king tide in 2015. So we can see that almost all type of transportation infrastructures are vulnerable to the sea level rise. So since the problem of sea level rise seems to be imminent, we should be prepared for it, and we should adopt appropriate measures to mitigate this issue as well. The first measure that we can say that can be implemented is to do early prediction. If you are able to know how much sea level is going to rise, we can adopt additional measures after that. So first we should predict the possible sea level rise. For this we can use different tools developed by NASA and NOAA to visualize the scenarios of sea level rise. After that we can apply vulnerability assessment to identify possible flooding areas. Then using other GIS tools like ArcGIS or QGIS as a base program, we can integrate different data from various sources for further evaluation of transportation infrastructures that can be affected by the sea level rise. Another method is to raise the land and road structures. Raising land above the sea level can help drain the water and reduce the tidal flooding as well. In this method, we need to periodically increase the level of roads, structures, and lands so that their height would match the rising sea levels. The one benefit of this technique is that it allows the areas to remain above the possible advancing water and maintains its functionality. But the thing is that this method should be done along with the increment in sea level rise. There was news that Miami Beach was raising its road by 2 feet in 2015, and since 2017 it is reported that Miami Beach has raised about 11 miles of its road to prevent flooding from rising sea level. The third method for the prevention of the coastal transportation infrastructure flooding caused by the rising sea level involves the construction of various structures like dikes, seawall, storm surge barriers, and other defensive installations. Uh, Actually, this process demands meticulous planning and requires a more initial investment compared to the alternative of elevating land as discussed earlier. These structures are not only designed for the present sea level but are intended to account for the future rise in sea level as well. Therefore, their design and implementation involves considerations beyond immediate circumstances as well. The figure on the left, figure 16, is of the dikes constructed along the coast to control the flooding. Similarly, along with this one, sea walls or barriers can also be constructed to prevent the transportation infrastructures. Another method is a retreat method. A retreat strategy is a simple method to directly ignoring the issue and addressing the consequences. And the approach of retreat and accommodation involves strategically abandoning and relocating the infrastructures in vulnerable areas. In less developed region, this might happen naturally over time, whereas in a densely populated area, it requires intentional plannings and reallocation of infrastructures away from the risk zones. Moreover, this strategy necessitates rethinking and redesigning transportation system to adapt to the changing coastline. So the figure 16 is of a newspaper article by Quartz, which mentions that a narrow island called as the Isle de Jean Charles in the southeastern Louisiana that is slowly sinking into the Gulf of Mexico. And now the resettlement project is ongoing, where 40 miles north of the existing island, a higher and more safe location is being selected as a relocation site. With the settlement, a new transportation infrastructure will also be constructed. So this is the another method that can be considered to prevent our infrastructures. Therefore, in conclusion, as we consider the impact of rising sea levels on our transportation system, it is important to note that these effects haven't been precisely quantified yet. However, to better understand these risks, we can employ geospatial analysis to map vulnerable infrastructures. Then we can overlay these maps with floodplains, which can help us to assess potential threat more effectively. Moreover, it is also that the decisions that we make today regarding our transportation infrastructures carries immense weight in the shaping future adaptability. Therefore, we have to employ forward-thinking approaches in our infrastructure planning to either limit or enhance the capacity of these infrastructures to cope and flourish on the ongoing challenges of rising sea levels. Hence, these are some of the references that I used for this presentation. And that is all for now. If you have any questions and queries, you can reach out to me with this email. And once again, thank you for your attention.